Achondroplasia, Wikipedia article audio. Achondroplasia is a genetic disorder that results in dwarfism. The arms and legs are short, while the torso is typically of normal length. Those affected have an average adult height of 131 cm for males and 123 cm for females. Other features include an enlarged head and prominent forehead. Intelligence is generally normal. Achondroplasia is due to a mutation in fibroblast growth factor receptor 3 gene. In about 80% of cases this occurs as a new mutation during early development. In the other cases it is inherited from one's parents in an autosomal dominant manner. Those with two affected genes do not typically survive. Diagnosis is generally based on symptoms, but may be supported by genetic testing if uncertain. Signs and symptoms. Causes. Treatments may include support groups and growth hormone therapy. Efforts to treat or prevent complications such as obesity, hydrocephalus, obstructive sleep apnea, middle ear infections, or spinal stenosis may be required. Life expectancy of those affected is about 10 years less than average. The condition affects about 1 in 27,500 people. Rates are higher in Denmark and Latin America. The shortest known adult with the condition is Giotiamj at 62.8 centimeters. Achondroplasia is caused by a mutation in fibroblast growth factor receptor 3 gene. In normal development, FGFR3 has a negative regulatory effect on bone growth. In achondroplasia, the mutated form of the receptor is constitutively active and this leads to severely shortened bones. The effect is genetically dominant, with one mutant copy of the FGFR3 gene being sufficient to cause achondroplasia, while two copies of the mutant gene are invariably fatal before or shortly after birth. A person with achondroplasia thus has a 50% chance of passing dwarfism to each of their offspring. People with achondroplasia can be born to parents that do not have the condition due to spontaneous mutation. Studies have demonstrated that new gene mutations for achondroplasia are exclusively inherited from the father and occur during spermatogenesis. It is theorized that oogenesis has some regulatory mechanism that prevents the mutation from being passed on in females. There are two other syndromes with a genetic basis similar to achondroplasia: hypochondroplasia and thanatophoric dysplasia. Achondroplasia can be detected before birth by prenatal ultrasound. A DNA test can be performed before birth to detect homozygosity, wherein two copies of the mutant gene are inherited, a lethal condition leading to stillbirths. Clinical features include megalocephaly, short limbs, prominent forehead, thoracolumbar kyphosis, and midface hypoplasia. Complications like dental malocclusion, hydrocephalus, and repeated otitis media can be observed. The risk of death in infancy is increased due to the likelihood of compression of the spinal cord with or without upper airway obstruction. Diagnosis. A skeletal survey is useful to confirm the diagnosis of achondroplasia. The skull is large, with a narrow foramen magnum, and relatively small skull base. The vertebral bodies are short and flattened with relatively large intervertebral disc height, and there is congenitally narrowed spinal canal. The iliac wings are small and squared, with a narrow sciatic notch and horizontal acetabular roof. The tubular bones are short and thick with metaphyseal cupping and flaring and irregular growth plates. Fibular overgrowth is present. The hand is broad with short metacarpals and phalanges, and a trident configuration. The ribs are short with cupped anterior ends. If the radiographic features are not classic, a search for a different diagnosis should be entertained. Because of the extremely deformed bone structure, people with achondroplasia are often double-jointed. The diagnosis can be made by fetal ultrasound by progressive discordance between the femur length and biparietal diameter by age. The trident hand configuration can be seen if the fingers are fully extended. Radiologic findings. Another distinct characteristic of the syndrome is thoracolumbar gibbous in infancy. There is no known cure for achondroplasia even though the cause of the mutation in the growth factor receptor has been found. Although used by those without achondroplasia to aid in growth, human growth hormone does not help people with achondroplasia. However, if desired, the controversial surgery of limb lengthening will lengthen the legs and arms of someone with achondroplasia. Usually, the best results appear within the first and second year of therapy. After the second year of growth hormone therapy, beneficial bone growth decreases. Therefore, GH therapy is not a satisfactory long-term treatment. Treatment. Achondroplasia is one of several congenital conditions with similar presentations, such as osteogenesis imperfecta, multiple epiphyseal dysplasia tarda, achondrogenesis, osteopetrosis, and thanatophoric dysplasia. This makes estimates of prevalence difficult, with changing and subjective diagnostic criteria over time. One detailed and long-running study in the Netherlands found that the prevalence determined at birth was only 1.3 per 100,000 live births. Another study at the same time found a rate of 1 per 10,000. Epidemiology. Based on their disproportionate dwarfism, some dog breeds traditionally have been classified as achondroplastic. This is the case for the Dachshund, Basset Hound, Corgi, and Bulldog breeds. Data from whole genome association studies in short-limbed dogs reveal a strong association of this trait with a retrogene coding for fibroblast growth factor 4. Therefore, it seems unlikely that dogs and humans are achondroplastic for the same reasons. However, histological studies in some achondroplastic dog breeds have shown altered cell patterns in cartilage that are very similar to those observed in humans exhibiting achondroplasia. Other animals. A similar form of achondroplasia was found in a litter of piglets from a phenotypically normal Danish sow. The dwarfism was inherited dominant in the offspring from this litter. The piglets were born phenotypically normal, but became more and more symptomatic as they reached maturity. This involved a mutation of the protein collagen, type X, alpha 1, encoded by the COL10A1 gene. In humans, a similar mutation has been associated with Schmid metaphyseal chondrodysplasia, a relatively mild skeletal disorder that is also associated with dwarfism. The now extinct Ancon sheep was created by humans through the selective breeding of common domestic sheep with achondroplasia. The average-sized torso combined with the relatively smaller legs produced by achondroplasia was valued for making affected sheep less likely to escape without affecting the amount of wool or meat each sheep produced. Research. Gene-based therapy is being studied. In June 2015, BioMarin announced positive results of their Phase 2 study, stating that 10 children experienced a mean increase of 50% in their annualized growth velocity. EDAR, PTCH1, BMPR1A, IL2RG.